So we have worked through graphing polynomial inequalities, and now we're going to switch our focus onto graphing rational inequalities. If you remember, that word rational has the prefix ratio, so that means all of the inequalities that we're going to see from here on out in my examples are going to be fraction equations. Okay, so how does this switch from the steps of solving polynomial inequalities, where we set it equal to 0, we find our solutions or boundaries, we put those on a number line, we test the intervals on the number line to see whether it's positive or negative, and then we select our appropriate intervals. It's pretty much the same thing for rational inequalities. The only thing is now we have one additional step, is we need to focus on our domain, or we need to focus on our vertical asymptotes. And the reason that we need to put this in here is because the graph can switch between above and below the x-axis about our vertical asymptotes. So we need to make sure to not only put our zeros or intercepts on the number line, but we also need to make sure to include these vertical asymptotes as well. Okay, so let's go ahead and just get into an example here. So I have 4x minus 5 over x minus 2 is less than or equal to 3. Well, we know the first step is to set it equal to 0. So I'm going to move my 3 to the left-hand side and everything else on the other. So I'm going to do that by subtracting 3. And now I want to focus on the domain. Remember, domain, specifically when we're just talking about fractions, is my denominators cannot be 0. Or if I were to find the vertical asymptote of these individual pieces, so just focusing on the fraction portion, I know that that denominator cannot be 0. So I know that my domain is all real numbers except when x is equal to 2, because 2 will give me a 0 in the denominator, which is undefined. And that means I have a vertical asymptote at x equals 2. So I need to remember that because I need to put that on the number line as well as my intercepts or zeros. Okay, that's the only additional step that we have between polynomials and rational equations. So now I just need to take my rational equation and I need to actually figure out where it is equal to 0. So I can treat this just like an equation. Now there's two ways that you might go about this. The first way is to put this as one fraction with one common denominator. But we did a whole section on solving rational equations. We did that magic trick, and so our magic trick was to multiply each part of the fraction by my least common denominator. And that least common denominator is over 1. And when we do this, all of our denominators should disappear. On the left, since I have a subtraction, I need to distribute it through. Okay, what happens then is the x minus 2 over the x minus 2 cancels out here, so that leaves me with 4x minus 5. But when I distribute it through here, I actually need to keep it because I don't have any denominator to cancel it with. So I have a negative 3 times that x minus 2. On the right-hand side, 0 times anything is still 0. So I have just reduced this now down to a polynomial equation. So nothing changes from what we've been doing in our previous examples. Let me go ahead and distribute the negative 3. Don't forget to distribute the negative as well. So that gives me 4x minus 5 minus 3x plus 6. Or that gives me an x plus 1 is equal to 0, or x is equal to negative 1. So this is my intercept or my boundary. So I need to put my boundaries and my asymptotes on my number line. So my number line includes negative 1, and it also includes 2. Now we need something to separate which is which, because this is going to be a big difference when we see those inequalities that have the or equal to, like this one does here. So negative 1 is a boundary. I'm just going to leave it as is. If you want to put a dot there to say that represents an intercept, that's fine. And then 2 is an asymptote, so I'm actually going to draw it like an asymptote to remind me that's what it is, so I don't accidentally select it in an answer where it shouldn't be. Okay, so now I need to do my chart with my intervals. So the x values that I'm going to use, less than -1, I'll pick -2. And between -1 and 2, I'll pick 0. And beyond 2, I will pick 3. Okay, so now we need to figure out what do we actually plug it into. Well, we need to plug it into the equation where it is set opposite of 0. So that means we need to plug it into this equation here. Now, this equation is fine, but we know that we like to typically plug it into the factored or the simplified version of this equation. Well, we actually did simplify it. This here is my numerator, and this here would be my denominator. So if I were to actually put this together, that would give me in fraction form the numerator of x plus 1 over my common denominator of x minus 2. So that's what I'm going to plug my numbers into. Okay, so don't forget you need to plug it into the top and the bottom, the numerator and the denominator. When I plug -2 into the numerator, -2 plus 1 over -2 minus 2, on the top I get a negative, on the bottom I get a negative, and negative divided by negative gives me positive. So over here I have positive, which tells me it's above or it is greater than 0. Okay, in the middle, if I plug in 0, 0 plus 1 over 0 minus 2 gives me positive over negative, which gives me negative. So this one here is negative or below, or less than 0. When I plug in 3, I get 3 plus 1 over 3 minus 2, which is positive over positive, which gives us positive, which is above. Okay, so now all I need to do is I need to select my appropriate answers. So this inequality is specifically less than or equal to. So I'm looking for where it's below. So it's below here, that's my less than, and equal to. It is equal to 0 here. It is not equal to 0 here because that is undefined there. And so that's the big difference between separating our intercepts and our asymptotes. Our asymptotes will never be part of the answer in our rational inequalities. Okay, so my answer then is going to be -1 up to 2, but I will not be including 2 because 2 is undefined. And so this is my answer there. And let's take a second to graph this and double check, see if that makes sense. Okay, so I have my graph up here. I also included my vertical asymptote here. So we can see that vertical asymptote on the graph, and we should see that that's never going to be an answer. And for this particular graph, we are looking for where it is less than 0, meaning below my x-axis. And so we see that starts right here at -1, and it continues all the way to my vertical asymptote. But this is an indication that our vertical asymptote should not be included in our answer. So -1, including it, all the way up to 2, not including it. And that is the answer that we came up with right here. So we're good to go. Okay, so in the next video, we're just going to be doing another example of the same thing.